Hello, guys. Welcome to the sCrypt Meetup again. I think today we have Andrew with us. Welcome here. So I think mostly we'll be talking about the latest article we published, page contra hash. But if we have more questions, for example, the back to Genesis, we can also briefly talk about it too. So, gentlemen, have you got a chance to look at the so-called page to contra hash yet? Or?
I looked at it briefly. It reminded me of back in the days of Ethereum when you would have like kind of like a forwarding address. I don't know if I read it right, but if you wanted to upgrade the contract, then you would be able to like upgrade it. I don't know. Am I on track with that, or did I totally misunderstand it?
I think I put an analogy. So saying that in Ethereum, right, you have two types of accounts. It's account model, right? So-called account model versus our UTXO model. So account, there are two types of account. One is it's like a Bitcoin address, right? So it's controlled by like some individual. It can be multi-sig, but usually it's controlled by private keys, right? So that's one type, they call it the externally owned address, EOA account. But they also have the kind of like a pure contract account, meaning this account, even the address looks like the same as the external user address, but it has no private key behind it. It's not derived from public key. So it's like a totally independent smart contract. If you send funds there, no individual can move it. Only the contract itself is in like a full control, custodial of the funds. So that's why I think most of the smart contract, the idea is coming from. It's not by individuals, but by, yeah, I think that's what they come up with the idea, like code is law. I mean, because the fund is actually controlled by code, but code is law is another topic anyway.
So how does this really? Oh, go ahead. No, go ahead, Andrew.
Sorry, I did read the page of contract hash, and I didn't understand what a hashed map was, and I would really like to
hash map
line by line later. Yeah, the first state is hashed map.
Oh, okay. Let me actually pull up the video. You mean this? Oh, this is like a hash map, like a hash table, a mapping. Pretty much like a key value store. Okay. Kind of, yeah.
It's kind of like it's like a dictionary, but you can't go in one backwards way, right?
Yeah, it's just a dictionary. You can think about it, the easiest way to think about it. Yeah, most languages have this, right? So in Solidity, it's called mapping. I think in JavaScript, usually just call it just object. It's just key value. And a lot of other hash table. Yeah, as you said, some call it a dictionary, some call it associative array. But it's pretty much the key value store. Yeah. You have a key, you can find the value in constant time.
Awesome. And it has some limitations, I think, from a dictionary. So maybe it's not totally correct to call it a dictionary, but it's similar to a dictionary.
Yeah, the only difference, yeah, you can even go to the, we have go to the documentation. So there's a standard library. You go to standard contracts, libraries. Yeah, hash map. Yeah, I'm going to share in the group. So if you want to check out later, it's kind of like a hash map, but it's the only difference is because we cannot do dynamic memory allocation. So instead of store the original key and the value, you store the hash of them. So that's the only difference. So we call that instead of hash map, we call it a hash map. So, but when you use it, it's more or less like a hash map, regular hash table. Yeah. Okay. So how about this? I will briefly go over this, and then if you have any anything unclear, we can then you can interrupt me at any time. Okay.
Sounds good.
So hopefully I go through this. You don't have to read everything. So the reason why we propose this is to address some, in our minds, severe limitations for the smart contracts so far. Meaning, if you look at all our contracts, for example, you go to like some token or even auction for any contract, after you program it, right, you deploy it. And then once you deploy it, it's immutable. So, which is a good thing, and sometimes not convenient, because what if you have a token, right? Let's say you want to be able to redeem it as some, merchant later on, or if you want to integrate it with some kind of like I don't know, kind of exchange later on, but it's not convenient because when you design it, those apps may not be even there. So that means you cannot integrate with others applications easily, right? So that's one. The second is, if you are like have a crystal ball, right? You know all the future applications that's coming in, let's say, next 50 years, and you want to support all of them, right? So what do? You just code all of the support features in the contract. For example, in this token contract, then you can support all the future applications because you already know them. But here's the thing, right? You may support 50 of them, but most of the time, if not all the time, you are just interact with one at a time, right? For example, you are interacting with this, merchant discount coupon, right? Or you are doing exchange with some other BSV, right? Let's say people are buying this token pay the token with BSV, right? It can be an NFT or anything. But here's the thing, right? If you put all of them together, the original contract token is going to be enormous. And most of the time is not used. So it will just cause the transaction bloat and higher transaction fee, which is not good. So to address both of these problems, so we have a very elegant solution we name it a pay to contract hash. So basically means instead of sending this kind of like a crypto asset, like it can be Bitcoins or tokens, fungible, non-fungible, instead of sending it to like a user controlled address, you can send it to a hash of a contract. We also use the same hashing algorithm, right? With the Bitcoin address, which is, you first do SHA-256 and then you do wrap-MD. So together, we do the double hash. So for the contract, we can hash of its content. Mostly is script, right? Because contract, when you compile it down, it's going to be locking script. So it's kind of like a unique ID, right? For people who are dealing with the backdoor Genesis, it's like a fingerprint for each contract. I know its behavior, and I can reference it by its hash. And the good thing about this hash is because it's using the same like a double hashing algorithm with the Bitcoin address. So from the appearance, it looks exactly the same. It's similar to like Ethereum. So if I give you some, address, right? 0x and then 20 bytes, kind of like a hex, then you cannot tell me whether this address is owned by somebody using some private key or is like a pure contract address, which means it's not derived from public key. Is where a contract resides at, the account. So same thing here. So I give the example. I think I use all because it applies to any kind of crypto asset. And so for here, for ease of exposition, I just use NFT because it's much easier to demonstrate. But the idea is it's straightforward to apply to any other crypto assets. Maybe it's BSV or fungible token, anything. So if you look at the NFT contract, what's in essence, right? It's just what's this contract? It has to store some kind of like a ownership table, right? Saying which NFT, which I denoted with ID field with the integer, and what is rightful owner. So in our previous contract, we also have this table, but you can see the difference. So the ID is just unique incremental integers, to uniquely identify each FT. And then is owners. This is users. They have the private key that can move the FT. That's the rightful owner, Alice, Charlie, or John. But here the difference is, instead of have a user here, you can also send it to the address, meaning it's address contract's address, meaning the hash of the contract script code. So in this way, the good thing is you can solve both of the limitations at the same time, because this address, it can be anything, it can be like a token sale, it can be token exchange, it can be redemption as some like any merchant for like a coupon, or you can be like a ticket, right? You can be represent any scenario you can imagine is programmable. So that means when you first, the good thing, right? For the limitation one, when you code this contract first, you don't have to know what this contract does. Right? You just allows, okay, if this match this contract fingerprint, then this FT3 that can be moved, they can be transferred. Right? But the content of this contract is not known when I first program this token contract. So that means, first of all, anybody who wants to add new features to use my NFT contract, they can do so. But of course, they have to send the NFT first to the contract address first. And then second means, because I don't have to hard code all the features the NFT is going to support in the future, I only have to support like a generic interface here, which I think I briefly cover here. This code is much more compact. It doesn't have to bloat. Does this make sense so far? Any questions?
Yeah, I mean, it makes sense to me. It's kind of, I don't know if I communicated it clearly in the first thing I said, but in the past, like people would have a contract that they wanted to be able to update in the future. And so there'd be like this way of I don't know if they forwarded it or something, but there was some sort of mechanism to update it, which I mean, obviously it's useful for this kind of stuff, but it also introduced some sort of security issues, whereas like, well, this could like change on me. And so, but one of the things you said in there was that it has to go through the contract's address or something. And so maybe there's a way of really knowing when it's going to change, or I don't know. I think it's definitely going to be useful in some circumstances, but it also adds some complexity where if you're assuming this contract's never going to change, but if it could change, maybe there's some issues with that.
I keep getting distracted by the idea that Alice and Bob are actually contracts, and they just use like a private public key pair in the contract so that only they can unlock it. And
yes.
now, so you could have these definer contracts, and then you can also have these owner, user contracts. And then it's just defining what can go on between these people and businesses or whatever.
Yeah, that's why I think this, if you really want to, to be strict about the terminology here is a little bit of vague, because here there's also like you can think of it as it's all Bitcoin smart contract, right? Meaning it's represented in script, but because usually I call this not a contract because it's like a pay to public hash, right? That's like a standard default way people hold the Bitcoins. So if you think about the way you interpret it, it's also correct, right? This is also contract, but it's also like a standard contract, right? They used to call it a standard transactions. So yeah, it can be anything. Even for
what I'm thinking is they could actually have this new kind of contract as well if there was a need, rather than just a plain public key hash.
Yes, yeah, yes. So the only difference is I can see is, so if an owner is like a person behind this, you only have to use the private key for this person, right? But here, you can use private key to sign. You can also have any other kind of like a constraint. For example, right? You need to know some kind of like a puzzle to some solution to some hash puzzle, or you need to provide, some solution to a mathematical equation. It can be anything, right? So this is more generic. Think about that way. So I think this should be even clear. If you look at I just briefly go over the code because it's just a few lines. So if you look at the FT, the implementation, right? Basically, we have this like a hash table. So more or less, it's like a hash table, like hash table, or a dictionary, whatever you call it. So basically, it's a key value store, right? So the key here is just this ID, it's an integer, and then the owner is a public hash, basically Bitcoin address, right? So it's just a one-to-one mapping. So when you transfer from let's say Alice to Bob, what do? You just here, right? Alice have to sign and then put the owner, which is the next owner's name, and then use, for example, here, if it's let's say Alice wants to transfer this to Charlie, what needs to happen in the NFT contract? Very simple. So you need to check. Okay, this is okay. We have a new guy coming. Okay, so this is actually authorized, right? So basically, it's a pay to public hash. You hash the public key, make sure this matches whatever in the table, and then you check the signature is good. So that's how you usually when you transfer FT from Alice to, let's say, Charlie, and then you set the Charlie to you basically you modify the entry, right? Changing this Alice to Charlie, and then how you want to prevent anybody else to move it, right? So Alice has to sign. That's how it authenticates. I think it is in the original one, it's the same. If you want to transfer, right, very easy. You check the signature and then you update the entry. So the rest is like a boilerplate. We don't have to worry about it. But you can see the difference here, right? We have another way to authorize. So in this is how the contract hash comes into play. So this part, I think, is a little bit detailed, but what it does is very easy. It's very simple, actually. So basically here, this is a token, right? A transaction can have multiple outputs. So basically, this is the token contract I have here. For example, from moving from Alice to Charlie, right? And then only thing I have to make sure is, okay, does it involve another input that spans a contract I'm expecting? So you have to kind of like check my neighboring inputs and make sure this input is spending from the contract I want, because I can get the contract, I can then hash it and make sure this matches what the owners of, right? For example, here, right? I want to change FT3, I have to move it because this does not have a legit private key, right? So I cannot use this if branch because there's no such private key to give me a valid signature to move it. So it has to go here. So basically, this is very easy. You just get the previous transaction. This is all like a all push transaction. So if you know the technique, you just get the pre-outs. This contains the kind of like the out points from all inputs, and then you can from this input you can read this out point. Right? Out point has two parts. First is the transaction ID, and then you also have the out point index based in the output index. So you part it, you get these two parts, and then you hash the transaction to make sure this is the transaction containing the contract here, right? So here you push this transaction here, so you check against the transaction ID. That means make sure it matches, right? because that's how transaction ID is computed. So once you match it, you know this transaction is good, then you can parse it, right? You know the output index, you know the raw transaction, you can parse it, and then you get the script part. So once you have a script, we call it the contract hash, right? You just hash the contract and make sure it is matches whatever in the table. So after that, it's the same. You can let's say transfer the token 3 under the control of this contract to, let's say, Charlie. Then you from there on, it's the same. So the only difference is here. Instead of using private key to a signature, you use the P2 contract hash to check. Whenever you move this token under a contract's address, you have to, also have to unlock this contract here. So this contract then can place any arbitrary constraint, right? Because this can be any arbitrary contract. You can place any constraint. You can say, oh, somebody gets this address get paid this amount. You may have 3 outputs. You may evenly split. So the token logic is decoupled from the whatever this contract does. Any questions so far? Welcome, Joe. If you have questions, ask, interrupt me at any time.
Thanks. No, I was just on that Twitter Spaces yesterday, so I figured I'd tune in and just listen to some
Okay,
more
sure.
details.
Nice, nice. Yeah.
One question. So wouldn't the contract eventually bloat if you were pushing the contract raw TX into the every update? Or just make the contract updates occasional? Is that the answer?
Yeah, good question. So here's the thing, right? It all depends on what this contract does, right? So a lot of time it doesn't have to be like a persistent. Basically, it's like a one-time thing, right? So this contract, for example, I can give this example. So this contract, it does not contain state. So basically, once you spend it, it's gone, right? You don't have it does not persist. So it doesn't matter how big it is. It does not become part of the token contract state. So it does not lead to the bloating issue. For example, give one example here, right? So this contract is very easy. How do you unlock it? You pay certain Satoshi amount to a certain address. So in this one, you can combine this contract, for example, token sale, right? So that means if token is under, let's say 3, is under control for this contract for token sale, right? So how do you unlock it? You have to include this contract, and this contract makes sure it can only be unlocked if somebody pays the seller, right, certain amount is the price. So in this way, it doesn't have to bloat. That's one thing. Because once you spend, the token is back, right? It's the same size, and this one is gone. So this output is just to receive the payment for when you sell the token. So every time you want to sell, you construct such a new UTXO again with the same script code, right? But it's a different transaction, of course. So yeah, if you design well, it doesn't bloat. It doesn't increase in size actually. Makes sense?
Is it applicable to fungible tokens as well, or just NFTs?
Yeah, it can be anything. Yeah, it can be. This can be holding fungible, non-fungible. It can even have to be any contract that holds, let's say, just BSV, just Satoshis. Can be anything. I think this example is just to demonstrate how it works. If you use NFT, because it's just easier for the code to show. Make sense so far?
So if I have these balances, oh no, it's really only, in this example, it's really only saying who can spend it and then they get it after it's spent, but you couldn't say how much each person has or anything. I guess I'm hopefully looking forward to like a UTXO version of this where you could maintain different balances and stuff.
The UTXO version, what do you mean? This is all UTXOs.
I mean, the contract would divide itself into different balances, or the contract, when someone spent it, the contract would make 2 new contracts with different balances based on the inputs of the spender, so that it could scale to have, 50,000 different balances.
You mean the balance? You mean the token balance, or what balance you're referring to?
Yes, the token balance defined in the contract, hopefully. I don't mean Satoshi tokens, I mean contract tokens.
Okay. Yeah, because if you want to do that right here, right? So this, in this example I just give is the token, somehow they can refer to the contract, right? By its hash. You can also do the same thing because this contract can be anything, right? You can also refer back and say, oh, this is the token, I can read its content. Then I make sure, for example, if I use this contract, I can only move, just give like a hypothetical example, right? This NFT in this transfer can only move to, let's say, OpenSea, right? I don't know, I'm charging like commission or anything, or maybe this output has to contain 3% platform fee, right? It can be anything. You can, yeah, you're right. I mean, in this example, I'm using the contract to refer to call this contract, but you can also do the same thing. In the contract, you can also read this content, right? And then place any constraint here too. So if not, I can just keep going. So how do you use this in reality, right? Let's say you want to, I just give this example. This example very easy. This is a contract. So this contract only unlocks if you give certain address, certain amount of satoshis, right? Using the output transaction. I think I'm not going to cover the detailed output transaction here. Hopefully everybody who's listened to here is already familiar with it. So how do you use it? Actually, you have to do 3 steps. So first one, right? If you want to, let's say, combine these 2 contracts, right? That's what interoperable means. You have a token contract. You also have a token sale contract. So before, if you want to, before this pay to contract hash, right? Now you can see the difference. If you don't have this technique before, you have to put this logic. You must combine this code. You must put it here, because if you don't add the sale function feature, you cannot sell your token, right? It's just because once you deploy, it's immutable. If there's some features missing there, you cannot add it later. Versus here, right? So if you have pay to contract hash, if you want to add a feature, oh, I want to sell my token now. So you can construct another contract called token sale, and then you combine it with this token contract, right? So here, what do? Whenever you want to sell the token, you first transfer it. Let's say Alice wants to sell his token to Charlie, right? So Alice first transfer the token to the contract hash address, contract's address. So basically, in here, Alice just signs and then move it to a contract. Let's say this token sale contract. So, and then when it's ready to be sold, you have to construct this transaction, right? That contains the contract. So you can deploy your token sale contract here, and then you can move the token you want to sell from Alice to this contract address. Basically, it's just a hash of the script code. And then you can create transaction 3 combining these 2, and then the token is moved from the contract to Charlie, and at the same time Alice is get paid here. So that essentially means you you just have atomic way to sell your token, right? So either both go through or non go through, because this is a single transaction.
Now, I may be getting a bit excited here, but does that mean that Alice can now send it to, I mean, Charlie already had it and Alice has it. Can Alice sell this token to Bob now and prove that it's real and not, it sounds like possibly yes.
Can send it to Bob? What do you mean?
Yeah,
Not
sell
Bob.
to another third party, you know?
Oh, Alice does not now. It is already sold. She has already sold to Charlie. You mean after
Okay.
before? Or what do you mean? It's already changed hand.
Yeah, can it change hands again?
Oh, you can keep doing this. But here's the thing, right? If Alice has sold it, she has no control of the original token anyway, which is token one, right? Basically, if Alice now sold it to Charlie using this technique, and here this is Charlie, right? Alice does not cannot control FT1 anymore. But of course, Charlie can do anything too. You can sell it, resell it. You can, redeem it if he wants to send to some like I don't know, like a merchant discount contract. So basically, anytime you want to add new feature, you first move your token temporarily to under the custodial of some contract address. And then after it's done, you're coming back to normal user as owner, and then you just keep going. So it's like this FT can be morphed into anything.
Who has the authority to morph it though? That's what I'm a little bit confused about.
The owner, right? Because
Just the owner, okay.
move it to of course, because if you, otherwise that you have issue, right? The token can be moved to anybody, right? So it depends on you.
Yeah.
You want to sell it, you move it to selling address, a contract address. If you want to, redeem it, you send it to some address that can redeem it. The owner, right? The owner have full control all the time.
I think also it's important to remember that this could be, and you said it a couple of times, but it's important to remember this could be any type of contract. It doesn't have to be
That's
an NFT or whatever. And so it's just if you have any type of contract and you want to somehow be able to change the rules of that contract, then if I understand correctly, you're going to send it to some special, I guess, I don't know. I guess I just totally don't, I don't totally understand it, but that could just be me.
Yeah, the easiest way to understand this is like, usually you send some assets to like a Bitcoin address, right? And this Bitcoin address, usually there's a private key behind it. But in this case,
right,
you can be just it can be, this address is not, it's not derived from public key, but it's derived from the hash of some arbitrary contract. So that means you have crypto assets, you cannot be only managed by private keys. You can be only be managed by any arbitrary sophisticated contract. It's similar to like a Ethereum model. So the Alice and Bob is like they call it a user account, which has a private key behind it. But a lot of other accounts also, they don't have private key corresponding to it.
right.
It's just code, right? It's just the code. Same concept here.
So, but what's the significance when you say that you're going to send it to a hashed contract? I guess that's the part I don't understand. Why, like, what do you mean? So now you've hashed it, but what is that? I mean, from my understanding, every like locking scripts is controlled by code in Bitcoin SV. It's just that some of them, if you call them like a user account, they're just going to be a pay to public key hash or something where it's unlocked with a private key. But now you're saying you're creating some sort of locking script with a hashed, the hash of the code That's the part where I think I got lost.
Basically, you are calling another contract. How do you refer to it? It's like you call function, right? You have this, you must have function name. You have to need some kind of like ID to refer to it. And the hash,
Okay.
we know, right? It's like fingerprint, unique ID. If you
Okay,
have
okay,
something, let's say it's like almost like a unique ID. You are like this contract, you can integrate with, you can call any other contract. How do you reference it? By using its hash, right? That's the only place the hash. But the trick here is you use the same hashing algorithm when you derive a Bitcoin address. That means, let's say if I'm Alice, I want to send it to some address, right? If you just give me the address of this contract, I don't know whether this is a regular user or this is a smart contract. I don't know because just from the appearance, it's all 0x and then 20 bytes, hex bytes. I cannot tell, but that's a good thing, right? And that means because any contract you can hash it and then call it. So that means your old token can integrate with any arbitrary contract. That's the amazing part, right? So basically it can be anything. And here's the thing, right? When you design your own token or any contract, you don't have to know. And you probably don't know what's coming next, right? Because you don't know the future. So somebody else can independently develop some other contract. And then but then you can still call it later on, even you don't know it beforehand. You don't have to hard code it. So that's a good thing, right? Because the whole reason we have this idea is to address some limitations. One is you cannot add new features. The second is if you add all the features that's ever you are going to support, it's going to bloat. So with this technique, it's like one stone, you kill two birds together. Yeah.
I like the fact that you can update it later, but I'm more excited about the fact that it's a unique identifier which you can provably use to spend different token balances and not be able to fake it.
You mean for the token contract itself, not including this?
Like when it says serves as a unique identifier, the
Yes.
contract hash serves as a unique identifier.
Yes.
So in order for someone to spend this token, they're going to have to use that unique identifier every time, every transaction.
Yes.
So that means I can decode that transaction and know exactly what code. Oh, well, I'll only know if the code worked if I can spend it out of that contract, I believe.
And then you can uniquely identify the contract, right? You cannot fake the contract because the hash is in its hash is here, right? So you cannot, because it's checked, right? Every time you check, this is good. You know for sure you are calling the correct contract. Nobody can fake it, right? Unless we talk about a hash collision, but that's like very unlikely. We don't consider that possibility. Yeah, if you assume the hashing is good, that means you are calling the absolutely the desirable contract. Let's say you're here, right? You're Alice, you want to sell it, and then you first hash this contract, right? And then you transfer from Alice to this contract's address. Then there's no way somebody else can steal it without paying you, right? In this example, you are selling it. But here, yeah, that's another great way. I think we also published something before. So basically, we call it the inter-contract call. It's the same technique by using different scenarios. Basically, you have a caller transaction, you want to call somebody. You can also use this hash to identify it. It's almost like you call somebody function. How do you know it's a function? You use its name, right? But instead of using its name, you use the hash to uniquely identify it. Nobody can cheat. You know exactly by its hash, you know exactly what the contract is going to do. Nobody can cheat. So yeah, actually, after I publish this, I'm even thinking about whether this can be used to solve the back to the genesis problem. But I'm still thinking, yeah. But the so far is you're kind of moving all the burden from the size for the unlocking arguments, but you're just shifting, but still the whole transaction is the same size. So maybe it's useful, maybe not, just something, another dimension to tool that can help us. Yeah, you can also maybe think about it along that line. Now we have some new tools to play. Right?
Who's the inventor of this?
Oh, it's sensible. So sensible
Sensible.
token. Yeah, I just because they talk about it, but they never write anything, and I want more people to know about this. So I just kind of republish. Yes, which is pretty good. I think this technique is entirely conceived by them. I just know about it like I think a couple of weeks ago. I think it's very cool. So I just write this article so more people can know about this, can use it. They use it in the token swap actually. So basically they have an FT and then they want to integrate it with the token swap, right? Because when they first devised the sensible token, the token swap does not exist. But how do they make sure it's future compatible? They just use a P2CH hash. And then whatever new contract they come up later, right? For example, token swap, or let's say Uniswap, they want to integrate with them. They can just transfer the existing token to the contract address, right? And it can be anything. That's the most powerful thing. This contract can be arbitrary. It can be token swap. It can be like some redemption, or you can be some like I don't know, let's say staking or even a movie ticket. It can be anything. So if you've not take a look yet, so I strongly recommend to check out. Just check out smart contract from Sensible. They have a lot of good techniques to use. They are the most advanced use case for sCrypt so far. So yeah, for me, a lot of time I'm just reading the stuff, and then if I've come up with new ideas, I think which can be applied outside of Sensible, I just write some articles to show the people sCrypt community how to use them.
Yes, please keep doing that because I don't see any of their stuff. Do I need to be on like
Hello?
Weibo or something to get their
Say it again. I think I lost you for like 5 seconds.
please keep publishing their stuff, and do I have to be on Weibo to get their new stuff, or where is it at?
Oh, they have a Twitter, Discord. I think they also have I don't know. I think they have a Telegram. I just joined yesterday because yesterday somebody from Slictionary, they were asking how to contact them, and they are in the sCrypt Slack channel as well. So they just publish some Telegram channel. You can also join there if you want to get instant feedback. I think I put the contact in the channel as well, so just in case you want to know more about it. Okay, any other comments, thoughts about the P2CH hash? Yeah, I'm excited. I think I want to see more people I'm interested to see what kind of new interoperable applications people come up, build upon this. So anything? Closing thoughts?
I don't have anything now.
Okay.
No.
Stefan, you've been quiet. You have anything? Welcome.
Hi, thank you.
Hi.
Hello.
I'm sitting here on my Friday evening and having some beer, so I didn't want to be in screen, but
Okay.
it looks really interesting, and I have to learn more about this, but I'm gonna contact our programmers and see
Programmer?
how
Yeah,
we can use this.
cool. Yeah, what better way to spend your Friday evening? Beer, sCrypt, tech talks. So
Yeah, right.
okay, that sounds like a good way to spend a Friday evening.
It is actually. Yeah, yes.
Very good. Okay, are you just curious? Are your team members like a programmers starting playing with sCrypt, or is it still, just sideline? Just want to see what that kind of things can do. Maybe it can be integrated into Unisat. Or
No,
what's
we
going
haven't
on there?
we haven't looked into that yet, but I'm planning that we should do it, and hopefully we can do it now. We have just started a new investment round,
Oh,
and
congrats.
are going to start looking for new people, or more people,
Okay.
not new, more people.
Oh.
And as soon as we have more resources, we're going to look into a lot of interesting things. So,
Very
and
good.
this is one of them, absolutely.
Okay.
I'm
Yeah,
super excited about this and trying to following as much as I can, but yeah, it's a lot of it's a lot of administration to run all the companies
I
now.
know,
So,
I know. Especially
unfortunately,
raising funding is not a it's not a Friday evening thing. I think yeah, I've just gone through that too. So
yeah,
hopefully I can get more people off too this year. So
yeah, nice.
so if you still remember, we kind of like I kind of did like a brief introduction about sCrypt almost 2 years ago, right? Is it?
Yeah,
Yes.
exactly.
That's your
We
group?
had just started then, and
That's like years ago. That's almost, is it 3? I kind of, yeah.
I think it was
3?
beginning
COVID.
of 2020 something.
Oh, okay. Yeah,
Yeah.
COVID really messed up with the time. So
Yeah, it's
it will
incredible.
be, yeah, if you want to kickstart, sCrypt in your team, I would more than happy to, give an update talk again. Hopefully this time more user friendly than last time, because last time I think 2020 we barely started. We haven't even launched the formally the IDE yet. So
Right. No. Right.
I think we only have the web version.
Yeah. It was. Yes. You were
Okay.
talking about it that it should be published at the time, but
Okay.
you hadn't done it yet. So no, you have made huge advances since then, and yeah, we should really look more into this and learn how to do that. So.
Okay, great. Yeah, let me know.
Absolutely, we'll do that.
So I'm more than happy to, show the Unisoft what the latest state of art is. This is
yeah.
Cool.
It's really amazing. I'm trying to follow it, but yeah.
Yeah, it's a lot of things. Yeah, I think.
Yeah.
I have to spend all my 24 hours to also to own this. So it's a lot of.
Yeah,
things.
I can imagine. You're doing a really great job. I'm really
all right.
think that, yeah.
All right. Anything else, gentlemen? Or we can call it a day for Friday.
I don't have anything. So
that's good. All right, everyone. Happy Friday and enjoy your weekend. Hopefully see you soon. Okay.
Sure.
Cheers.
likewise.
Bye.
Cheers. Bye-bye.
Have a good weekend, guys.
You too.
Thank you.
Bye-bye.